guys, we're going to go through how to find a centroid and how to find an orthocenter. We'll start with centroids, and the bare minimum you need to be able to do is find the midpoint of each line and draw the median in to get your centroid, which is the point where all medians meet. Keep in mind, centroids always meet inside a triangle, regardless whether it's acute, right, or obtuse. For extra credit, or like I might make it worth 1 point, where basically if you want that A, you need to earn it, you're going to have to use equations of lines and find out what this centroid actually is. Okay, so it's very easy to draw it. We're going to then kind of review equations of lines to find the exact point, because a lot of times the centroid of a triangle will not fall on the exact point of the graph, like it doesn't right here. It falls on a spot where you're going to end up with fractions. So our first step is find the midpoint of each line. So D, E, F are 3 midpoints, and I literally just connect opposite vertices to opposite midpoint. And we draw a line AE, we draw a line BF, and we draw a line CD. And those are my 3 medians. When it's an obtuse triangle, it's the same deal. We find my 3 medians, and I draw opposite vertex to the midpoint. A to E, C to D, and B to F. Now this centroid works out very nicely. It ends up working out as 0.32 as our centroid. Now, what also works nicely is if you look at CD, what do we say about a centroid? C to the centroid should be twice the centroid to the midpoint. Well, that goes up 2, that goes up 1. So C to the centroid is double centroid to the midpoint, which is what should work out. Also, C to the centroid is 2/3 of the line, and the centroid to the midpoint is 1/3 of the line. So that's a nice little check right there. A lot of times, though, the centroid's not going to end on an exact point for you, so that's kind of a break right there. If we want to find the actual centroid, the exact value of it, and we can kind of check our work through this with the distance formula as well, here's what we do. The first thing I'm going to do is I'm going to find the line from BF, and you're going to see me go back and forth here a little bit. My line from BF has a slope of -1 and a y-intercept of 1. So the equation of my line is y equals -x plus 1. If I add x to both sides, the standard form of my equation is x plus y equals 1. Now if I go to my line CD, that has a slope of 5. If I keep going up another 5 and over 1, I end up with the y-intercept of 9. So here we have a slope of 5, up 5 over 1, up 1, 2, 3, 4, 5 over 1. My y-intercept is 9. So the equation of this CD line, or the median coming from C, or vertex C, is y equals 5x plus 9. So y equals 5x plus 9, I subtract 5x on both sides, and I multiply everything by -1. 5x minus y equals -9. And then I do a systems of equations with my 2 lines. The y's cancel, I'm left with 6x equals -8, and my x equals -4/3. -4/3 plus 7/3 equals 1, so my y is 7/3. So that's my centroid, -4/3, 7/3. And if you look on the graph, -4/3, I'm slightly to the left of -1. 7/3, I'm slightly above a y coordinate of 2. So it does make sense. The graph should kind of dictate to you where the point should be. Checking my work if I really wanted to, what I do is I do distance formula. -4, 5 is my vertex. Okay, so as I come here, -4, 1, 2, 3, 4, -4, 5 is my vertex of B, the distance to the centroid. So when I use distance formula, -4 minus 4/3 is a -8/3. 5 minus 7/3 is an 8/3. I square both of them. I get 128 over 9, and we simplify that radical as 8√2/3. When I go from my centroid to my midpoint of 0, 1, I get 0 minus a -4/3 squared, plus 1 minus a 7/3 squared, and that ends up being 16 over 9 plus 16 over 9. -4/3 or +4/3 squared plus a -4/3 squared. We get 16 over 9 plus 16 over 9, which is 32 over 9 under the radical, and that's 4√2/3. Now, if you add that together, 1, this is double this, which is what it should be. 8 root 2 over 3 plus 4 root 2 over 3 is 12 root 2 over 3, which is 4 root 2. Okay, because 12 over 3 reduces to 4. So 8 root 2 plus 4 root 2 is 12 root 2 over 3. We keep our common denominator. 12 root 2 over 3 is 4 root 2. Here, if I find the length of the entire median, negative 4, 5 to 0, 1, well, that's negative 4 squared plus 4 squared, square root of 32, which is 4 root 2. So this math will work out at every single level. Finding altitudes. Finding an altitude of a obtuse triangle, the orthocenter will be outside the triangle. Okay, on a right triangle, the orthocenter is on the triangle at the right angle, and for an acute triangle, the orthocenter is inside the triangle. The first one here is an obtuse triangle, so my orthocenter is here. Once again, here's how we do it. The slope of AB is negative 3 over 1. So from the vertex opposite, if I need a perpendicular line, this slope is negative 3 over 1. That means I want a slope of 1/3. Doesn't make much sense to go up and to the right because I need to go toward my AB line. So I go down 1, left 3. Down 1, left 3. Down 1, left 3. My slope of BC is 1, 2, 3, 4, up 2. So it's negative 1/2, down 2, right 4. So my slope from A, this vertex opposite BC, has to be a positive 2 over 1. Once again, it doesn't make much sense to go up 2 over 1. So I go down 2, left 1, down 2, left 1, down 2, left 1, and down 2, left 1. And then finally, from vertex B, I'm going up 1, 2, 3, 4, 5. Excuse me, 1, 2, 3, 4, 5. Left 1, 2, 3, 4, 5. So my slope is a negative 1. So I need a positive slope of positive 1, my opposite reciprocal, from B. Up 1 over 1, and now I'm going down 1, left 1, 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 and I draw my line in. My orthocenter is negative 5, negative 4. On your test, when it's an obtuse triangle, I'm going to make sure that the orthocenter ends up at an exact point. Now, it won't happen that way for an acute triangle. Same deal. My slope here is negative 1 down, or down 1, so negative 1, 1, 2, 3, 4, so negative 1/4. So my slope coming from A should be a positive 4. I can go up 4 over 1 or down 4, left 1. Down 4, left 1. Coming this way, my AC line is up 1, 2, 3, 4, left 2. So it's a negative 4 over 2, so the slope is negative 2. So my opposite reciprocal is 1/2. Up 1 over 2. Up 1 over 2, and that's enough to get me through. And then finally, AB has a slope of 1, 2, 3 over 2. So it's 3/2. So this slope should be negative 2/3. Up 2, left 3. Up 2, left 3. And that's how I draw my third orthocenter in. Now, if I want that exact point, which it looks like it's between negative 1 and negative 2, and 2 and 3, well, my vertex from B is up 1 over 2, up 1 over 2. So my y-intercept is 7/2, and my slope is 1/2. I subtract negative 1/2, or subtract 1/2 x on both sides, so it's negative 1/2 x plus y equals 7/2. Multiply everything through by negative 2. X minus 2y equals negative 7. From A, this line has a slope of 4, so it's up 4 over 1, we have a y-intercept of 9. So y equals 4x plus 9, we subtract the 4x, and we multiply everything by negative 1, we get 4x minus y equals negative 9. And then I come to here and I do my system. X minus 2y equals negative 7, 4x minus y equals negative 9. I multiply everything by negative 2 here, and we end up with negative 8x plus 2y equals 18. And now we combine like terms. Negative 7x, the y's cancel, and we end up with 11. divide by negative 7. My x is negative 11 over 7. When I plug that in for x, negative 11 over 7 minus 2y equals negative 7. I multiply everything by 7 to get rid of the denominator. Negative 11 minus 14y equals negative 49. I add 11 to both sides. You get negative 11, or negative 14, excuse me, negative 14y equals negative 38. We divide both sides by negative 14, and we get y equals 19 over 7. And there's my orthocenter.